But what we discovered soon after this migration was that all these features really came at a pretty high price. Part of Datadog's pricing structure is that you actually pay per unique time series that you're storing with them. So if we build as 1,000 different unique time series. So let's take a little bit of a look at what that looks like in practice. So here we have an example metric. This is actually the past week of bits per second that Quantcast serves. And this is a metric that an engineer pretty commonly might look at to diagnose performance issues or try to investigate a root cause of some sort of bug. But internally, this metric, actually, we're not reporting just this metric. It's an aggregation of many different metrics submitted from each of the hosts that are running our service. So here's a graph of the same metric broken down by individual hosts. And this is, kind of an interesting piece of impressionist art, but this graph really tells us almost nothing useful about our system. For this metrics and most others, we really don't care about the value on a per host basis. We care about aggregations, averages, percentiles, things like that. And so you can kind of see here how one single metric, bits per second, explodes into thousands of metrics the more hosts that you have. So as we had more and more custom metrics, we found that our costs were really growing really, really rapidly. What we realized was that we're storing all of these useless data points on a per host basis when really what we care about are the important aggregations. So when we saw that our costs for Datadog were high based on the number of custom metrics that we were having, we thought about how we could potentially reduce the number of granular per host data points that we're storing and instead just store the aggregations that we really care to look at and monitor and alert on. So just for some background, in our initial configuration, we're using a really standard setup. Each of our hosts runs a monitoring agent, in our case, the Datadog agent. This agent receives our metrics over statsd and then periodically flushes them to Datadog for long-term storage. And as you can see here, each host collects all of its own metrics and submits them separate from any other ones. So one thing that we started thinking about as we were thinking of ways to improve the system was Datadog's implementation of statsd histograms. So what that would do for us was for a metric here, like total bits per second, it generates aggregations, like the median, the sum, and the average. And we thought that initially this could be really useful. We could just extract out the aggregations that we want rather than storing all these useless data points. What we eventually figured out was that the statsd histograms actually come from every single host. So each host submits its own median, its own average, and in the end, we ended up with way more metrics than we had originally. So this didn't really fit our use case at all. We then considered another option where instead of running a Datadog agent on each host, we would run a central agent. So all of the machines would then flush their metrics over statsd to the central agent, which would aggregate them together and eventually flush them to Datadog. But while this might work in theory, clearly the central Datadog agent is a huge single point of failure. A failure in that one node would take out all of the monitoring for all of our hosts, which obviously wasn't acceptable. We also needed a way for this central system to have no way to scale in response to load. If we scale up the number of hosts that we had, or the number of metrics that we're sending, and the central agent started responding poorly, we would obviously experience loss of metrics for all of our machines. So this didn't really fit our use case either. Fortunately, a team at Stripe had pretty much all of our problems and open sourced a tool called Veneur, which provides high performance metrics aggregation. Veneur is a really flexible system that either replaces or runs alongside your standard monitoring agent as a local metrics collector. And it lets you generate aggregated time series from multiple hosts in a highly available manner. So what Veneur does is sit between each individual host and Datadog. Each individual host runs a local Veneur collector, which also receives metrics over statsd. It's actually protocol compatible with the Datadog agent, which is really easy for us. And just like in the previous setup, these ingest metrics over statsd, and this time they flush them to a central Veneur aggregation service. This service then performs the aggregations that we care about, percentiles, sums, averages, and then finally flushes that to Datadog. A cool aspect here too is that the per host collectors don't just flush raw data values to Veneur. To enable percentile calculations, it actually uses a data structure called a T-digest. T-digests make it possible to do really efficient, fast online approximate histogram calculations. from many different hosts. It's easy to combine multiple t-digests, and it makes Venure's implementation of calculating percentiles really, really fast. So previously, we talked about the issues with running a single central monitoring agent. Unfortunately, Venure can be configured in such a way that it solves all the problems of that approach. In this high availability setup, a proxy set of proxy Venures runs behind a TCP load balancer, which takes all the metrics that we're receiving from our local Venure collectors. It then looks at a list of global Venures with performance aggregation and uses a consistent hash ring to translate each metric to a specific global Venure. And all the proxy Venures forward all their metrics to that single global aggregation Venure. That global Venure will then aggregate metrics and finally flush them to Datadog. So the end result is that each global Venure really handles a subset of the total space of metrics that we're processing. So in the case, for some of the failure cases that we talked about before, in case of a node failure, the proxy Venures will detect a failure in one of the global Venures, and it'll rebalance all of the metrics to handle to all the healthy instances. Additionally, if there's more load and we need to scale up, we can scale based on CPU usage, number of metrics, and dynamically add or remove global Venures, and all of the metrics will automatically rebalance between them. So this really solves the two major problems with the other approach, where there's no single point of failure and it's able to dynamically scale based on load. So as you can see, Venure fit our needs in a lot of ways, but didn't really have everything that we wanted at the start. So we contributed multiple large features to the project. We added support for additional multi-host aggregations, so you could combine you could combine data from multiple hosts with different aggregation functions like average, sum, min, max, and others, where Venure used to only support percentiles. But in order to do this, we actually needed to make changes to some of Venure's internal APIs, the different components used to interact with each other. So to make our change and future changes easier, we actually added a new gRPC mechanism for communication between Venures. This is still an optional feature. It's currently in the project. We've actually been using it for a while. We've noticed some really awesome performance gains from it, about 3 times reduced system resource usage on our machines. And this is compared to the previous JSON over HTTP implementation. So once we implemented changes to Venure that would meet our needs, we started doing a phase migration. We first switched all of our real-time systems so that they would send metrics to both Venure and as host-level metrics in Datadog. We moved all of our dashboards and alerts, once this had been done, to use the aggregated metrics. And then finally, we went back and disabled most of our granular host-level metrics in Datadog. And the end result was a 50% reduction in the amount of metrics that we were storing, and by extension, a really huge reduction in our cost. At the same time, we basically lost no useful data that we actually would have monitored for other. Even better, we actually had some more useful metrics now that we had true multi-host percentiles provided by Venure. Having true multi-host percentiles means that if you ask for the 95th percentile, you actually get the 95th percentile of all samples across all hosts running your service. And this isn't true in some monitoring setups. Oftentimes, each host or metric collector will compute its own, say, 95th percentile based on just the samples it knows about, and then that's stored in your monitoring system where it might be aggregated later by whatever system is going to be doing your graphing. And so the true multi-host percentile in this approach is actually 2 very different things. So here you can see 2 different graphs based off the exact same data. One is a true multi-host percentile computed by Venure, and the other is average percentiles from lots of different hosts. And clearly there's some pretty noticeable differences between the 2. The average particularly, you can see, looks like it damps some big spikes that the true percentile shows. So there's some pretty sizable differences between these. To visualize this difference, we can look at another really ugly mashup of colors. And these are all the individual 95th percentiles that are averaged together to create that blue line that we just saw in the other graph. So clearly, the average of all these values is statistically a very, very different value from just the actual 95th percentile of all of the samples. And this is, as we saw before, it makes a pretty big difference. So there really is a big difference between these true multi-host percentiles and some sort of approximation of it by averaging together lots of different percentiles. This has a lot of applications. One that we took advantage of it for was for tracking performance improvements in our real-time bidding stack. We were able to accurately measure the tail of our performance, the 95th and 99th percentile of our system, again, that's processing many bids per day, as we were rolling out new performance improvements across thousands of hosts in real time, which was really useful. And so it's important to know a good number of monitoring systems don't do true multi-host percentiles like this. So if you're monitoring a system that runs on many, many different machines, it's important to understand this when you're looking at these statistics. I hope it's clear at this point that we at Quantcast have gotten a huge amount of value out of using Veneur to pre-aggregate our metrics. We were able to cut the costs of monitoring of our custom metrics for our real-time systems by 50%, while losing pretty much no usable data along the way. And we also were able to get increased visibility into our systems by having true multi-host percentiles. And of course, if this sounds interesting at all, my team at Quantcast is hiring. We're solving interesting problems around Kubernetes and Service Mesh and others similar to the one that I just talked about. So please get in touch with me or Terry Olson, who's here, if you're interested. Again, pre-aggregating metrics and using Veneur has been extremely valuable for us, and I hope that might prove useful for some of you as well.
Talk about having that extra granularity in your metrics. Was it able to unlock anything that you may not have been aware of prior? Any big wins from that, even that little bump that we saw there?
I think it was particularly useful for, like I talked about, we had used it a lot to track performance improvements for our stack. I think what that showed, from what I understand, was just small differences where we actually saw a lot of our metrics before we were using this averaging method. It seemed really inaccurate. They didn't really match up with what we were seeing. So it seemed like there was a difference by having the true percentiles. It's hard to clearly measure what the what the impact was, but it definitely seemed like there was a difference from looking at it. So, yeah.
So you mentioned Service Mesh. If I'm using Linkerd or Envoy between my services, or is in fact a scale-out service I'm going to have to discover, especially as Canonical grow. And if you said you're using GCP load balancer, maybe using Service
Mesh. We're not yet. The way we're running it right now is behind AWS Network Load Balancer. So primarily the two systems that I talked about are running on still bare EC2 instances. So we're mostly using kind of systems outside of the whole Kubernetes Service Mesh ecosystem right now.
You mentioned that you are using the Service Mesh.
We're looking into it.
Okay.
Yeah, currently Veneur is not running on it.
Okay.
So we're going to see that.
Have you thought of, so the problem I've been trying to track down with some of these things is you basically have a loop. Because if you're using over Envoy or Linkerd and you try to do tracing and metrics for all the services, you don't want to do it for your metrics and service as well, because then it will be calling itself on every call.
Sure.
Which means you can't measure what you're measuring if you're measuring
Right.
So I was trying to figure out whether you would use a separate load balancer to break the loop. That's or you're not there yet.
Yeah, haven't really got there yet. Most of Veneur's internal monitoring is kind of correctly set up so that it avoids the whole problem of looping back on itself. At least for us right now, specifically for Veneur's use case.
Has anyone else seen a better option or solution for this? We just always, ex-Cisco guy, help build Google developer groups, we always use something else even if it isn't as good, because you can't trust your main system to tell the truth about itself. Structurally, what that has to be, it depends on what your stack is. Mileage will vary, and what your performance time loop is. A lot of times you can cheat by using a CDN if you're already using it for static things, or if you're using a data service that offers up actually statistics and metadata backend or URI provider. If you're big enough to have your own API, you got to serve a Firehose partner, but you never trust your main system for what to tell the truth about itself, no matter how bad the other data is.
Thank you.
Thank you, Noah. We're going to take about a 5-minute break, and then we're going to have the second talk of the night. So feel free to grab more pizza or beer. If anybody needs the restroom, they're down the stairs. Here, men's is closer to this room, women's is farther away from this room.
Nice.
Okay. Oh yeah, no worries.